on our bodies, we're able to store excess calories, but it's in the form of fat. And fat can get broken down into smaller molecules through catabolic pathways into things called fatty acids. And most of the cells in our body can really easily use fatty acids to get energy and run their processes on. But the brain is a protected organ. There's something called the blood-brain barrier, which makes it difficult for things to jump into the brain to protect it. But that also can prevent fatty acids from easily going into the brain. So the brain is primarily using glucose for energy. But what happens when we go periods of time without food is that we don't have a lot of glucose stored in our body. We do have some in the form of glycogen in our liver and our skeletal muscle, but it's not very much. It can only hold us over for maybe a couple of days. And at that point, then you have to start breaking down the fat. And fat, again, will get converted into fatty acids, which is great for most of the body. But the brain needs something special, and it needs ketones. So ketones are made when fat is broken down, and they are basically like tiny little water-soluble fat molecules. And those are able to cross the blood-brain barrier and make it into the brain. Animals in the wild and our early human ancestors regularly experienced episodic starvation and food scarcity. The average human can actually persist weeks or months without food, whereas without this adaptation, they think that most humans could only go a couple of weeks. So it was a very important step in human evolution.